Hello everyone, I am Dr. Milikul Sresht and today we will discuss Oswald dilution law. This special law is meant for the weak electrolytes. Weak electrolytes से पहले let us understand what are electrolytes. Electrolytes are those substances which allow the electricity and they dissociate on passing the electricity through them. When they dissociate, they do not dissociate in the same way. मतलब different type of electrolytes have the different type of tendencies. Means some of the electrolytes have tendency to dissociate completely when electricity is passed through them. But some of the electrolytes do not dissociate completely. They dissociate to a very small extent on passing electricity. So do remember, electrolytes can conduct electricity only in the presence of water, that is in their aqueous state, या फिर when they are in the molten state. For an example, if that electrolyte is salt, because salts are ionic in nature, suppose we are taking NaCl, that NaCl is made up of Na plus ion and Cl minus ion. But NaCl cannot conduct electricity in its solid state. When it will conduct electricity? When either it is in the aqueous state or it is in the molten state. Okay, so these can conduct electricity on the basis of whether that substance या that electrolyte is going to conduct या going to dissociate completely or is not going to dissociate to give you many ions. We have divided all the electrolytes into two categories. Strong electrolytes dissociate almost completely. Weak electrolyte dissociate to a very small extent. So that dissociation part, if we are talking about, we better define it in terms of degree of dissociation, that how much it is dissociated, that we can define using the term degree of dissociation. Why I am telling you this here? Because in Oswald dilution we will use this term called degree of dissociation. Degree of dissociation is expressed in by alpha. Okay, what is degree of dissociation? It is the fraction of the molecules dissociated from the molecules which are taken. जैसे 100 में से अगर 5 टूट रहे हैं तो I will call this degree of dissociation. I will take it in the percentage and I will say that 5% dissociation is there. That is the fraction of the molecule dissociated out of the total molecules taken is giving you, will be giving you degree of dissociation. So more is the degree of dissociation means more number of molecules, या bigger fraction of the molecule is being dissociated. Is it clear? So let us talk about this Oswald dilution law. And as I told you, this is for the weak electrolyte only. Why for the weak electrolyte? Because weak electrolytes dissociate to a very small extent, and after the dissociation, for an example, Ha dissociates. Ha is an acid which dissociates to give you H plus ion and A minus ion. If this is a strong electrolyte, suppose it is a strong electrolyte, तो अगर ये strong electrolyte है तो it will give you the product completely and ये पूरा टूट जाएगा, and we cannot apply the concept of equilibrium in this particular dissociation. Okay, if it is a weak electrolyte, then it will stop dissociating after a certain time. तो जब ये रुक जाएगा process means it is not going to convert into its ions. Okay, that time these ions will remain in equilibrium with these molecules, and that time we can apply that law of equilibrium to it. Okay, so this Oswald dilution law is applied for the weak electrolyte, those electrolytes which have tendency to break down to a very small extent, that after a small time, after a certain time, they come into the equilibrium state. I hope it is clear to you. So let us apply this concept using an example, and here I am taking an example of a weak electrolyte. We know this thing that this is a weak acid, acetic acid. It is going to dissociate in the presence of water to give you acetate ion and H2O plus ion, hydronium ion. If I apply the law of chemical equilibrium here, I can write as the K for this particular reaction will be CH3COO ions concentration, H3O plus ion concentration divided by CH3COOH का concentration and concentration of water. and this water is going to be in axis, hence it does not show the change in its concentration. तो इसको हम constant मानेंगे, and I'll take it here because it is also constant. So this will form K and HWO. Now what is left? CH3COO minus ion, H3O plus ion, and CH3COOH concentration. Now this is replaced by a constant called Ka, and this Ka is called ionization constant of acid. Which acid? This acid, whatever you are taking. So this Ka is called ionization constant of acid. Here I am using a term called ionization, which should not get confused with the term dissociation. These two terms are almost like terms, but the very small difference is there. For an example, if we are talking about the ionic compound, the dissociation of ionic compound is called dissociation. If polar covalent compound are being dissociated, their dissociation is called ionization. And we know this thing that acetic acid is a polar compound, and because it is dissociating here, I am calling it as ionization of acetic acid. If sodium chloride is being dissociated, I will call it as dissociation of sodium chloride to give you the ions of sodium ion and chloride ion. I hope it is clear to you. Now let us apply the concept of degree of dissociation so that we can derive the relationship which can define you the Oswald dilution law. So let's talk about this particular reaction which we have already taken here, that is dissociation, ionization of acetic acid to give you the ions acetate ion and hydronium ion. So let us just suppose that initially suppose I have taken C mole per liter concentration of acetic acid, and just because it was initial time, no product has been formed. It is not peak dissociated that time, so it is a starting time just because. Now at the time t, when the time is passing, after a certain time we will observe that out of C moles, C alpha has been dissociated. C alpha का मतलब है यहाँ पे, if I am taking 100 moles, out of 100 moles, suppose 5% dissociated. तो 5% dissociated किसके 5%? 100 moles के 5%. तो 5% of 100, 5% is alpha, 100 is C, the concentration you have taken before. तो 100 moles per liter थी concentration, 100 moles का 5% dissociated. This is what? C alpha. तो इतना amount is converted into the ions. Left out part is 5% has been dissociated, means 5 has been dissociated. So 100 minus 5 means 95 is left out. 5 is dissociated. So how many have been dissociated? Will be giving you the ions. So this is C alpha and C alpha will be the concentration of the ions which are being formed at the time t. ठीक है, अब इसमें let us apply the concept of equilibrium. So what I will write as Ka for this particular reaction is concentration of acetic acid, acetate ion, hydronium ion divided by concentration of acetic acid. So let's write down the values given there. C alpha divided by C minus C alpha. Can I write it as C 1 minus alpha? Because C I have taken common here. So C is cancelled. Alpha square C divided by 1 minus alpha. Now one thing you are clear here, that this acetic acid is a very weak acid, and just because it is weak acid, it is not going to dissociate too much. 5%, 2%, 3% it is going to dissociate. So one may say very small fraction will be dissociated. So here we can ignore the term 1 minus alpha will be equal to, almost will be equal to 1. So I am removing this 1 minus alpha and making it equal to 1. So this is how this equation changes. Ka will be equal to C alpha square. And how we can calculate the degree of dissociation then? Alpha square equals to Ka divided by C. So what is C here? C is the concentration. So concentration क्या होती है? Concentration is mole upon volume. If I am taking 1 mole here, so 1 mole upon volume. So if I am taking 1 mole here, so C I can replace with the 1 upon V. So can I do this? So C equals to 1 upon V, and this will turn into Ka over V. So if I take the alpha, value of alpha, root Ka V. So this is Oswald dilution law. आप चाहे इसे ऐसे लिखें या फिर you can write it as alpha equals Ka upon C. Both ways you can write down the Oswald dilution law. Oswald dilution law says that degree of dissociation of a weak electrolyte is directly proportional to the square root of the volume which is containing 1 mole of electrolyte, or it can also be represented as degree of dissociation is inversely proportional to the square root of concentration of the electrolyte. I hope now you are clear what is Oswald dilution law and what is degree of dissociation and how we are going to apply the degree of dissociation. And one more thing I want to share here, that is, can you see there alpha is increasing with the volume. Matlab, if I am taking a container, just imagine I am taking a container and I am taking 1 mole of electrolyte into it, which is a weak electrolyte. Here I am talking about. So if I am taking 1 mole of weak electrolyte in a given volume, okay, so this is the volume which is 1 mole of electrolyte. So if I am increasing the volume but which is containing 1 electrolyte, means I will not increase the amount of the substance, I am increasing the volume and adding water to it. So if the water is added, the dilution is done, then the degree of dissociation is increased. मतलब with the small amount of water, less will be the degree of dissociation. जैसे जैसे मैं पानी डालती जाऊंगी, the degree of extent of degree of dissociation will increase. For an example, if the little amount of water will dissociate 5% molecule, then on increasing the water, the dissociation will increase to 5 to 6%, to 6.5%, to 6.7%. More is the amount of water added to the weak electrolyte, more will be the dissociation of weak electrolyte. Same way, ये भी एक ही बात है, that is concentration कम होना. Concentration कब कम होगी? जब volume ज़्यादा होगा या 1 mole of electrolyte से कम आप डालेंगे. तो it's all about the ratio, that how many molecules of water are available to break down that particular molecule. So I hope this video will be helpful for you to understand this concept of dilution law, Oswald dilution law, which is only talking about weak electrolyte. If you like this video, please hit the like button, share it and subscribe my channel. Thank you very much.